In October 1983, Ken Thompson, the co-creator of the Unix operating system, received the Turing Award, which according to Wikipedia is generally regarded as the Nobel Prize equivalent for computer science. Ken did not only work on Unix, but also wrote the B programming language, which would later serve as the base for the C programming language, which is still one of the most used programming languages to this date. The Turing Award lecture of Ken posed a very interesting problem, which is still relevant today. To what extent should one trust the statement that a program is free of Trojan horses? Perhaps it's more important to trust the people who wrote the software. In the paper named Reflections on Trusting Trust, Ken explains a way to code a self-replicating Trojan horse. To understand how this works, we first have to roughly understand how a program is written. It generally goes as follows. First, a developer writes code in a programming language like C. This code is called the source code. The developer then compiles the code into a final program using a compiler, which is simply put just a piece of software that translates the source code to a binary, which is the executable that the computer can read and run. Compiled binaries aren't readable to humans. In general, compilation is a one-way process. You can't go back from the compiled binary to the source code. There are some exceptions to this rule, but that's beyond the scope of this video. Different programming languages will use different compilers. One important thing to note is that a compiler is also just a compiled piece of software that has been coded by someone. The C compiler used to compile Unix, for example, was written in C and compiled itself. If a software is open source, that means that the source code is public to everyone. Note that this doesn't mean that everybody can edit the original code, but people can make a copy of the source code and edit that. A great advantage of open source code is that it's generally very safe. If anyone would be able to insert a virus into the code, this will be very clear because anyone that would read the code can spot it. In the paper, Ken laid down a scenario. If someone would program a backdoor in the Unix operating system, that would allow the person that wrote the backdoor to log in on any Unix computer with a username and password that was chosen by him, anyone that would read the Unix source code could spot that backdoor because it was in plain sight. You can modify the C compiler that is used to compile Unix to check if it is compiling the Unix code, and if so, secretly implement the backdoor in the compiled Unix binary. Then you can't spot anything malicious in the Unix code, but if someone would read the source code of the C compiler, it would be clear something weird was going on. Someone could just remove the malicious piece of code and recompile the compiler, so that wouldn't work either. Remember earlier I said that the compiler used to compile Unix was written in C and compiled itself? Well, Ken's paper presents the following. What if somebody would compile a malicious version of the C compiler that checks if it's compiling the C compiler, and if so, inserts the code for inserting the Unix login backdoor into the compiler, and inserts the code that would check if it was compiling the C compiler? It is now possible to revert the source code to the non-malicious version and use the malicious compiler to compile a new compiler from the clean source. This new C compiler would be compiled from a clean source and still have the untraceable backdoor in it and the code that reproduces this behavior if it compiles a new C compiler. The entire virus has become untraceable. I find this such an interesting problem because it shows how hard it is to know a software is safe. And maybe it is indeed more important to trust the people who wrote the software than the software itself. Obviously, this is just an example that Ken used in his paper, but this applies to a lot more than just a C compiler. I will link to the paper written by Ken Thompson in the video description, and I strongly recommend you check it out. It goes into more detail and it's a very interesting read. Thank you so much for watching. I really hope you enjoyed this video. Till the next one.